Okay. So once again, very good morning all. So in the last lecture, we have started the chapter number 3, that is principal stresses and the strain. And in the previous lecture, we have covered all the basic concepts related to the principal stresses and the strain, and why this particular chapter is important as far as the calculation of the stresses on the irregular shapes or the inclined surface, or which is also called as the oblique plane. So in the previous lecture, by taking the reference of one rectangular body, we have discussed all the important definitions. That is, why sigma x and sigma y are called as the principal stresses, and if your member or the body subjected to the principal stresses, how to calculate the normal and the tangential stresses on the oblique plane and the inclined plane. And whatever the important definitions are there, that is starting from the principal plane, then principal stress, major principal stress, minor principal stress, major principal plane, minor principal plane, then angle of obliquity and the resultant stress. So that total 8 definitions we have discussed in the previous lecture, and we have started the case number 1, that is your member or body subjected to the uniaxial condition. That means there is only one force along the x-axis. That means it is subjected to the stress, that is sigma x along the x-axis, and accordingly we have solved the problems and we have calculated the normal and the tangential stresses on the oblique plane. So one more problem is there based on the case number 1 that we will solve, and then we'll move to the case number 2. So the third problem is there in front of you. In the previous lecture, what are the 2 problems we have solved? In that, the 2 varieties are there. So the problem number 1, where the value of sigma x, the value of theta, that is inclination of inclined plane, is given, and we have calculated normal and the tangential stress. Then second problem, whatever we have solved in the previous lecture, in that the normal stress they have given and they have asked to find out the tangential stress, but the inclination, that theta angle, is not mentioned in the statement. But we have to understand that the normal stress is purposefully given to calculate the theta value first, and that theta value we have to put in the sigma t equation for the further calculation. Now one more problem we'll take. So read the statement carefully. A bar of cross section 100 mm by 75 mm, that is B into D, the dimensions are given, is subjected to tensile pull of P shown in figure. So one bar is there, their cross sectional dimensions are given, that is 100 mm by 75 mm, and it is subjected to tensile pull. That means whatever the force is applied, it is in tensile condition, but we don't have that value, and that value will be considered as a capital P. The figure is also given, that is shown in figure, full stop. The permissible normal and shear stress on oblique plane or inclined plane AB are 100 Newton per mm square and 5 Newton per mm square. See, the permissible normal and the shear stress on oblique plane. So whatever the inclined plane we have considered, on that plane, whatever the normal stress is there, that normal stress is equal to 10 Newton per mm square, and another shear stress, which is also called as a tangential, that is also given 5 Newton per mm square. Respectively, determine load P oblique shape load P. So we have to calculate the shape value of load which is applied on that particular cross section of the member. So the figure is given. So the figure I will draw here. So draw this particular figure. So this is the member which is subjected to the load P. It is in tensile condition. Then there is a inclined plane. The angle is given with minor principal plane is 60 degree. This is 90 degree angle. This is your required theta value. Then This is normal stress which is perpendicular to the inclined plane. That inclined plane we have to consider as a AB. So this is A and this is B. So sigma n is equal to 10 Newton per mm square, and sigma t, that is shear, it is equal to 5 Newton per mm square. So this is the figure. The inclined plane AB is there, but initially whatever the angle is given, that is 60-degree angle, that angle is given with minor principal plane. The angle which is present at the left and right side, these are the major principal plane or vertical plane, and always theta we have to consider with vertical plane only. सिग्मा n आणि सिग्मा t च्या फॉर्म्युल्यामध्ये जो काय आपण थीटा व्हॅल्यू पुटअप करतो तो थीटा फक्त व्हर्टिकल प्लेनशीच अँगल केलेला असला पाहिजे. बट हियर इन द फिगर इनिशियली अँगल गिवन ॲज अ 60 डिग्री विथ मायनर प्रिन्सिपल प्लेन, म्हणजे काय हॉरिझॉन्टल ॲक्सिसच्या आपल्याला 60 डिग्री अँगल दिलेला. सो वी कॅन वी टेक दिस 60 डिग्री ॲज इट इज फॉर द कॅल्क्युलेशन? No. So by using this 60 or by using this 90 degree, that is trigonometric rule, we have to calculate the theta angle with this vertical plane. Okay, so first of all we'll write all the given parameters. So area, we can consider area AX is equal to 100 into 75. What is this answer? 100 into 75. Mm square. Then normal stress on oblique plane is given, sigma n is equal to 10 Newton per mm square. Tangential, which is also called as a shear, that is sigma t is equal to 5 Newton per mm square. Then theta is equal to 60 degree in front of that with minor principal plane, but we have to calculate theta with major principal plane or vertical plane. Therefore theta is equal to, what we have to do, 90 minus 60 is equal to 30 degree. It is with vertical plane. But as per the sign convention, whatever the four figures I have given for the theta consideration, as per the sign convention, whether that theta we have to take negative or positive?
Positive.
So here theta value we have to take negative. So in front of 30 degree you have to write down the negative sign, and in front of that write down as per sign conventions. As per sign conventions. So theta is equal to 90 minus 60. It is equal to 30 degree. त्याच्या समोर लिहा with vertical plane, आणि त्याच्या समोर लिहा as per the sign convention. Negative sign we have to consider for the further calculation. Okay, so these are the given parameters. Now we have to calculate the safe value. So here what I will do, first of all I will take the effect of normal stress. So what is the formula? Sigma n is equal to sigma x into cos square theta, and another formula sigma t is equal to sigma x divided by 2 into sin 2 theta. Now if you see, we have to calculate the safe load, that is P or Px. We have to calculate the safe load, that is P or Px. But for the calculation of Px, first of all we have to calculate the sigma x. Getting? Because we are having the formula. What is the formula? Sigma x is equal to Px upon Ax. Therefore Px is equal to sigma x into Ax. But for the calculation of Px, first of all we have to calculate the sigma x. Now I am having the two formulas for the sigma x calculation. By using sigma n also I can calculate the sigma x, and by using the sigma t also I can calculate the sigma x. So by using this sigma x I will get one Px value, and by using the sigma t formula once again I will get the Px value. At the end we have to compare the both values, and from that comparison we have to check what will be the safe value. Now please tell me, if one value you will get as a 150 kilonewton, and another value you will get as 100 kilonewton. So which will be the safe value? Whether minimum value will be the safe value or maximum value will be the safe value. दोन फोर्सेस आहेत, एक 150 किलोन्यूटन आहे आणि दुसरा 100 किलोन्यूटन आहे. तर 100 ला आपण सेफ लोड म्हणायचं का 150 ला आपण सेफ लोड म्हणायचं? Why? Minimum value means whatever the stresses are induced in that body, it is also minimum, and maximum value means stress value is also maximum. What is our requirement? Whether maximum stress value will be developed in body or minimum stress will be developed. जेवढे मॅक्सिमम स्ट्रेसेस तुमच्या बॉडीमध्ये डेव्हलप होणार आहेत तेवढे फेल्युअर होण्याचे चान्सेस काय असतात? जास्त असतात. मग स्ट्रेस व्हॅल्यू तुमची मॅक्सिमम मिळते म्हणजे तुमची फोर्स व्हॅल्यू पण काय असणार आहे? मॅक्सिमम असणार आहे. दॅट्स वाय प्लीज कीप इन माइंड द सेफ व्हॅल्यू ऑफ द लोड विल बी ऑलवेज कन्सिडर्ड ॲज ए मिनिमम व्हॅल्यू. आता इथं आपण कंपॅरिझन काय करतोय? कारण आपल्याला सिग्मा एन पण दिलाय आणि सिग्मा टी पण दिलाय, बरोबर. सिग्मा एन पण दिल्यामुळे आपण सिग्मा एक्स काढू शकतो आणि सिग्मा टी पण दिल्यामुळे आपण सिग्मा एक्स काढू शकतो. म्हणजे इथं पण आपल्याला पी एक्स मिळतोय आणि इथं पण आपल्याला पी एक्स मिळतोय. ठीक. जर फक्त त्यांनी सिग्मा एनच दिला असता, सिग्मा टी स्टेटमेंट मध्ये दिला असता तर आपण सिग्मा एनचा फॉर्म्युला वापरून आपण सिग्मा एक्स व्हॅल्यू फाइंड आउट केली असती आणि मग पी एक्स कॅल्क्युलेट केला असता. मग त्याच्यामध्ये सेफ व्हॅल्यू आपल्याला कन्सिडर करायची गरज लागली असती का? नाही. हेच आन्सर तुमचं फायनल आन्सर. सो वन बाय वन calculate, put the value of sigma, that is it is equal to 10. So sigma x into cos square of minus 30. So here you will get sigma x is equal to 10 divided by cos square minus 30. So what is the sigma x?
13.33.
13.33, correct. 13.33 Newton per mm square. So this is the sigma x. Immediately calculate. Then px is equal to sigma x into ax. So here sigma x 13.33 into 7,500. So what will be the px by using the normal stress equation? Okay, 99.97 into 10 raised to 3 Newton. So this is the px value by using the normal stress equation. So problem is very simple. By using the sigma n equation, we have to calculate the sigma x, and by using the calculated sigma x, we have to calculate the px value because cross-sectional area is also given. So this is the one px value by using the normal stress equation. Similarly, by using the shear stress, again calculate the sigma x value. So here sigma t is given 5. So sigma x divided by 2 into sine 2 into minus 30. Bracket complete. So here sigma x is equal to 5 into 2 divided by sine minus 60. Minus 30 into 2, correct? So what will be the sigma x? How much? Minus 11.54 Newton per mm square. Please check your answer. Minus 11.54 Newton per mm square. By using the shear stress formula or by using the tangential stress formula, we have calculated one more sigma x, and that is equal to minus 11.54 Newton per mm square. And then one more by using the same procedure, that is px is equal to sigma x into ex. So minus 11.54 into 7500. So px is equal to how much? minus 86.55 Newton per, sorry, into 10 raised to 3 Newton per mm square. Sorry, Newton. This is the force. So minus 86.55 into 10 raised to 3 Newton. So this will be the another force value. So here we got this negative sign due to the theta consideration as a negative. Okay, already they have mentioned the member or body subjected to the tensile pull of P shown in figure. म्हणजे फिगर मध्ये ऑल स्टेटमेंट मध्ये ऑलरेडी त्यांनी मेन्शन केलेलं की अप्लाय झालेला फोर्स हा कसा आहे टेन्साइल आहे. And now here after the comparison of 99.97 and 86.55, so 86.55 it is less as compared to 99.97. So which will be the safe value? 86.55. So while taking that value, don't take their negative sign. मग सर इथं negative sign आहे, मग तो force compressive असला पाहिजे. It is not like that. Due to the sign conventions of this particular theta as a negative, you got that particular sigma x as a negative value, and that negative sign conventions we have taken for the further calculation. Therefore, your value is negative. Getting? So effect of negative sign of that particular theta will not be considered in your final observation. So here write down one sentence at the bottom side, that is safe load is equal to minimum value of load. Safe load is equal to minimum value of load is equal to 86.55 into 10 raised to 3 Newton is equal to 86.55 kilonewton. So this will be your safe value. That means that member or body, it can easily sustain the 86.55. जर त्या बॉडीवर आपण 99.97 एवढा जर लोड अप्लाय केला तर there is a possibility of failure. Getting? So the body can sustain the load up to the 86.55 kilonewton without any failure or without any deformation. So this is the one problem based on the safe load calculation, and these are the some varieties based on the case number 1. So this will be the third variant of the problem we have discussed in the today's lecture. Previously, all the values are given. We have to calculate sigma n and sigma t. Then second problem, sigma n is given. We have calculated theta, and that theta we have used for the sigma t calculation. And now third problem is related to the both stresses on the oblique planes are given, and we have calculated the safe value. So this will be your case number 1, where member or body subjected to the uniaxial stress or axial stress. Okay, so these are the case number 1. Now we'll move to the case number 2. Put the heading case number 2, member or body subjected to biaxial stresses, and draw this particular figure. Member or body subjected to biaxial stresses. Now here why it is called as biaxial? Because the member or body subjected to the stress in x direction as well as in y direction also. Sigma x and sigma y both are there on the figure. Therefore, the condition will be considered as a biaxial stresses. Means during the calculation of normal and tangential stress on oblique plane, we have to consider the effect of sigma x and sigma y. Case number 1 मध्ये आपल्याला sigma y दिलाच नाही. That's why in sigma n and sigma t formula आपल्याला sigma y चा effect consider करता येतच नाही, because sigma y value will not be given or it is not given. But in the second case, both the stresses are there, that is sigma x and sigma y, and always 99% problems are there where sigma x value is always greater than sigma y in all the numericals. Please keep in mind, 99% problems are there where the sigma x, at least for these cases, case number 1, 2, 3, sigma x is always greater than sigma y. Okay. Now, so the case number 2, the name itself suggests that is biaxial stresses. Why it is called as biaxial? Because if you see on the major principal plane and on the minor principal plane also, the stresses are there. That is sigma x is there, and sigma y is also there. So this condition is called as a biaxial stresses. And now, while calculating the normal stress and while calculating the tangential stress on oblique plane or inclined plane, we have to consider the effect of sigma x and we have to consider the effect of sigma y. So this is a small portion separately I have drawn here. So whatever the portion is present here. So these separate portions I have drawn here separately. That is, it represents the normal stress which is perpendicular to the inclined plane, tangential stress which is parallel to the inclined plane, and in between them there is a resultant stress. Okay, and again the theta angle is given with the vertical plane. According to that, we have to take the sign conventions, or we have to apply the sign conventions, and we have to use that theta value for the further calculation. And now, so this is a list of the formulas for the case number 2. Now, if you see the formula number 1 and formula number 2, now it is there in the form of sigma x and sigma y. In case number 1, sigma n and sigma t are there in the form of sigma x only. And now here, both effect of sigma x and sigma y is considered in the calculation. So the first formula is sigma n, sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta. So cos 2 theta term is multiplied for only sigma x minus sigma y divided by 2. Please keep in mind. And calculation करताना पण त्या टर्मचं पहिल्यांदा सेपरेट कॅल्क्युलेशन करायचं आणि त्याच्यामध्ये परत sigma x plus sigma y divided by 2 ही व्हॅल्यू काय करायची ऍड करायची. Sometimes students are doing separate calculation of this term and this term and ह्या total multiplication ह्या total value ला याने multiply करायचं. So actually this is wrong. Getting? So this bracket is applicable up to this. So this is the common term. So cos 2 theta will be multiplied by only sigma x minus sigma y divided by 2. So do the separate calculation and then we have to do the addition. So many times students are making the mistakes in this particular calculation. So take the list of the formula in your notebook. Normal stress, tangential stress, otherwise sigma r, tau max and phi, angle of obliquity. There is no any change. These three formula will be common for all the three cases. So there is a change only in the normal stress equation and the tangential stress equation. Otherwise, all the remaining three formulas are same. You have to keep this particular list of the formulae in your mind because we have to use that formula while calculating the further values. There is a possibility of confusion in all the three cases. Okay, now we'll start with the numericals. So the problem number 1. See, the principal stresses at a point in a section of member are 100 Newton per mm square and 50 Newton per mm square. Both are tensile. So please keep in mind, figure is not given, only statement is given, and if the stresses are mentioned like that, 100 Newton per mm square and 50 Newton per mm square, in these both values, the first value always consider the sigma x, and second value will be your sigma y. 99% problems are there, I have told. 99% problems are there where the sigma x is greater than sigma y. Sigma x is greater than sigma y. So first value will be your sigma x, second value will be your sigma y. Both are tensile, they have mentioned. Full stop. Find normal, tangential and resultant stress across the plane passing through that point inclined at 60 degree to a plane having 100 Newton per mm square. बघा, theta angle कुठल्या कुठल्या स्टेटमेंट मध्ये मेन्शन केला जातो, that we have to understood through this particular statement. So the two principal stresses are there. One is 100 Newton per mm square. So represent on the figure. So this is 100 Newton per mm square. Both are tensile. So another, this is also 100 Newton per mm square. Another stress is also tensile, that is, which is equal to 50 Newton per mm square. And at the bottom side also it is equal to 50 Newton per mm square. So in the given also you have to write down all the values. Sigma x is equal to 100 Newton per mm square, in bracket write down capital T, that is tensile. Sigma y is equal to 50 Newton per mm square, in bracket again tensile. Okay, then see, find normal, tangential and resultant stress across a plane passing through that point inclined at 60 degree. Baga, what statement they have given? Inclined at 60 degree to a plane having 100 Newton per mm square stress. What is the meaning of this? The plane is inclined at 60 degree to that plane having 100 Newton per mm square stress. म्हणजे कुठल्या प्लेनशी दिला अँगल? वर्टिकल प्लेनशी, कारण ह्या वर्टिकल प्लेन वरच तुमचा 100 न्यूटन पर mm स्क्वेअर स्ट्रेस काय झालेला आहे? ऍक्ट झालेला आहे. गेटिंग? बट हियर दे हॅव नॉट मेन्शन, हियर दे हॅव नॉट मेन्शन which vertical plane. मग ह्या लेफ्ट साइडला दिलाय का राइट साइडला दिलेला आहे? So which we have to take? Normal. So this is the left side, this is the angle, and this is equal to 60 degree. So theta is equal to plus 60 degree with plane of 100 Newton per mm square stress, and we have to calculate sigma n, we have to calculate sigma t, and we have to calculate sigma r. So these are the values we have to calculate. So like that, first of all we have to generate the figure. We have to locate the position of sigma x, sigma y, and while considering the theta, we have to check whether it is given with major principal plane, minor principal plane, or horizontal axis or vertical axis. And accordingly, we have to decide their sign conventions, either theta is positive or negative, and then we have to go for your further calculation. Okay, so like that, we have to generate the figure for the case number 2. And I have told the first value will be your sigma x, second value will be your sigma y. Sigma x is always greater than sigma y. If there is a negative value, जर इथे sigma y जर तुम्हाला negative दिला असता, means compressive दिला असता, तर that negative sign also we have to consider in the calculation. But both are tensile. So draw the figure. And then go for the calculation. So one by one, first value we have to calculate as a normal stress. So we are having the formula. So first value is equal to normal stress is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta into cos 2 theta. So now only we have to put the values sigma x 100, sigma y 50 divided by 2 plus 100 minus 50 divided by 2 into cos 2 into 60. So sigma n is equal to, so try to go for the separate calculation. If you are able to do the all the calculations simultaneously, no problem. So it is equal to 75 plus, so what will be this calculation? Minus, so in bracket minus 12.5. So here this plus minus it becomes 75 minus 12.5. So your sigma n will be equal to 62.5. You check your answer, 62.5 Newton per mm square. So please check, send your answers in the chat box. Do the calculations properly. Calculation is very simple, but there is a possibility of wrong calculation here. So try to go for the separate calculation of the separate terms, and then you have to go for the addition. First of all, do the separate calculation of term which is present as a sigma x plus sigma y, and then remaining term sigma x minus sigma y divided by 2 into cos 2 theta. ह्या termचं separate calculation करा, and at the end you have to go for the addition or subtraction wherever it is required. So 62.5 Newton per mm square. This will be the normal stress on inclined plane. So you have to represent the position of normal stress on inclined plane like this. It is perpendicular to the inclined plane. So this is your sigma n, and this is your sigma t, and this will be your calculation. So sigma n is equal to 62.5 Newton per mm square. Then next, sigma t is equal to, what is the formula? Sigma x minus sigma y divided by 2 into sin 2 theta. So here sigma t is equal to 100 minus 50 divided by 2 into sin 2 into 60. So what will be the sigma t? 21.65 Newton per mm square. So please check the sigma t value also. 21.65. This will be the tangential stress on the oblique plane. Now, if both are calculated, then go for the sigma r. Sigma r is equal to, we are having the formula resultant of normal and tangential. So sigma n square plus sigma t square, which is equal to 62.5 bracket square plus 21.65 bracket square. So what is sigma r?
66.14
Newton per mm square. Please check your answers. Sigma n is equal to 62.5 Newton per mm square. Sigma t, that is tangential or the shear stress, is equal to 21.65. And last, resultant of normal and tangential stress, we are having the formula square root of sigma n square plus sigma t square. Put the value. First of all, make the square of both values and then take the square root, and then you will get the correct value, 66.14 Newton per mm square. 66.14 Newton per mm square. So this will be your resultant stress value. Okay, finish. I've got the answers. Resultant 66.14 Newton per mm square. Okay, then next. So the next problem, at a point in strain material is subjected to tensile stress of 120 Newton per mm square and compressive stress of 80 Newton per mm square acting right angle to each other. So whatever the strain material is there, it is subjected to the two stresses. One is tensile, another is compressive. So tensile stress is given 120. Compressive stress is given 80 Newton per mm square. But already I have told the maximum value will be considered as a sigma x and minimum value will be considered as a sigma y. So here sigma x is equal to 120 tensile, sigma y is equal to 80 Newton per mm square compressive, and both are acting right angle to each other. बघा sigma x and sigma y हे एकमेकाला perpendicular असतात. You can observe in the figure. Full stop. Find normal, tangential and resultant stress on inclined plane on a plane inclined at 30 degree with compressive stress axis. Whatever the inclination is given, it is given with compressive stress axis. So you have to take the reference of this statement and you have to draw the figure. So first of all, write down all the given parameters, that is sigma x is equal to 120 Newton per mm square in bracket tensile. Sigma y is equal to minus 80 Newton per mm square in bracket compressive. Theta is equal to 30 degree with compressive stress axis, and we have to calculate sigma n, we have to calculate sigma t, and we have to calculate sigma r. So these are the given. So draw the figure also. On the figure you have to represent all the stress values. So first is the sigma x, it is positive, so 120 Newton per mm square. This is also 120 Newton per mm square. So another stress is compressive, so you have to represent their direction also in the form of compressive region. So it is equal to 80 Newton per mm square. At the bottom side also it is equal to 80 Newton per mm square. So these are the axes. These are the axes. Horizontal axis आपण कुठला axis म्हणू शकतो? Tensile stress axis, बरोबर? whatever the 120 Newton per mm square stress is applied along the horizontal axis, त्याच axis ला आपण tensile stress axis म्हणू शकतो. Similarly, whatever the 80 Newton per mm square compressive stress is applied along the vertical axis, तर त्या axis ला आपण कुठला axis म्हणतोय? See, compressive stress axis. Why it is compressive stress axis? Because 80 Newton per mm square is the compressive stress and it is applied on the vertical axis. आणि त्याच्याबरोबर आपला प्लेन इन्क्लाइन झालेला आहे. So what we have to do? How to represent the inclined plane? प्लेन आपल्याला असा इंडिकेट करायचा आहे की त्या प्लेनचे इन्क्लिनेशन व्हर्टिकल ऍक्सिस ची किती डिग्री आहे? 30 डिग्री आहे. Then how to draw it? From which point to which point? For example, I will represent the point A, B, C, D. This is E, this is F, this is G, and this is H. Which 2 points you have to join so your inclination becomes 30 degree with compressive stress axis? And that we can take positive. 30 degree आपण पॉझिटिव्ह पण घेऊ शकतो किंवा निगेटिव्ह पण घेऊ शकतो. पण मी सांगितलेलं आहे स्टेटमेंट मध्ये जर तुम्ही दिलेलं नसेल तर always try to take theta always positive. Then which 2 points you have to join? A to F. Okay, one answer A to F. A to between B and F. कसं जॉइन करणार आपण B आणि F? ऑलरेडी B आणि F हॉरिझॉन्टल लाईन आहे ना. A to Any another answer? Whether can you join the A to F? It is very simple. बघा, हा जर मी inclined plane point A पासून point F पर्यंत काढला, getting? So this is point F and आपली definition काय आहे? Find out the resultant normal tangential and resultant stress on a plane inclined at 30 degree with compressive stress axis. हा तुमचा inclined plane झाला, बरोबर? त्या inclined plane ना compressive stress ची केलेला अँगल किती दिलाय? 30 डिग्री. बरोबर आहे. पण आपण काय सांगितलंय? Always we have to take that theta value which is made with vertical plane or major principal plane. म्हणजे आपला theta value कुठे असणार आहे? या कोपऱ्यामध्ये, बरोबर? What is this theta value? Why? There is one rule. There is one trigonometric rule. There is an angle rule. त्याला अँगल म्हणतात आपण. अल्टरनेटिव्ह अँगल, बरोबर आहे. हा तुम्हाला झेड डायरेक्शन मध्ये दिसतोय. इथून हा तिरका आणि परत हा वर. जर हा अँगल 30 डिग्री येत असेल तर as per applying the rule of adjacent angle, so this theta is also equal to 30 डिग्री. मग जर आपण थीटा इथं 30 डिग्री रिप्रेझेंट केला तर हा थीटा तुमचा पॉझिटिव्ह आहे का निगेटिव्ह आहे? as per our sign conventions it is equal to positive. So this theta once again we can represent which is equal to theta is equal to 30 degree with vertical plane. Like that you can write down the statement. So like this they are giving the statement to represent the theta. So how to join or which 2 points you have to join due to which our condition will be satisfied. So initially inclined plane I have represented like this आणि ह्याच्यावरचा तुम्हाला नॉर्मल स्ट्रेस फाइंड आउट करायचा आहे, याच्यावरचा तुम्हाला टेंजेन्शियल स्ट्रेस फाइंड आउट करायचा आहे आणि त्याच्यावरचा तुम्हाला रिझल्टंट स्ट्रेस फाइंड आउट करायचा आहे. Now you are having all the values sigma x, sigma y. Don't forget to take the negative sign of sigma y during the calculation. Otherwise your answers will be wrong. त्यामुळे sigma y लिहितानाच त्याला नेगेटिव्ह साइन द्या. If any stress is compressive or negative, While writing in the given data, you have to represent in negative. Therefore, we can take that negative value as it is in the calculation. So now the figures we have drawn, we are having all the values. Now go for the calculation one by one. So the first, sigma n is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta. So sigma x is equal to 120 plus sigma y in bracket minus 80 divided by 2 plus 120 minus sign as it is again in bracket minus 80 divided by 2 multiply by cos 2 into 30 or cos 60 directly we can write. So now one more step we'll write sigma n is equal to, so here plus is there, minus is there. So 120 minus 80 divided by 2 plus minus 120 plus 80 divided by 2 into cos 60. Then tell me the value of first parameter quickly. 120 minus 80 divided by 2. This is 20. Plus, do the multiplication of this entire term. How much? 50. Please check your answer. 120 plus 80 divided by 2. Tell us कितने multiply करते हो cos 60 ना, and that answer is equal to 50. So your sigma n is equal to 70 Newton per mm square. 70 Newton per mm square. So this is your normal stress calculation on the oblique plane. Problems are very simple, straightforward. But if you make the mistakes in the consideration of theta, your further all the values are wrong. फक्त त्याच्यामध्ये challenging task काय? Theta value. Getting? So if you see each and every problem, प्रत्येक वेळा theta value represent करताना प्रत्येक वेळी statement वेगळा आहे. In the problem number 1, they have given the theta value with plane having 100 Newton per mm square. मग आपल्याला तो 100 Newton per mm square हा vertical plane वर आहे का horizontal plane वर आहे ते आपल्याला पहिल्यांदा माहित पाहिजे. In the second problem, they have given the theta angle with compressive stress axis. तो theta angle वापरून and by using the rule of adjacent angle, we have converted that theta with major principal plane or vertical plane. So challenging task is consider the theta value. So sigma n is calculated. What is your answer in the chat box? Have you got 70 Newton per mm square? Do the calculations. Take the effect of negative sign. Sigma y is negative. So that negative sign also we have to take in the calculation. If you have calculated sigma n, then go for the sigma t calculation. So sigma t is equal to sigma x minus sigma y divided by 2 into sine 2 theta. So sigma t is equal to 120 minus in bracket minus 80 divided by 2 into sine 2 into 30. So once again sigma t is equal to 120 plus 80 divided by 2 into sine 60. So what is the sigma t value? 86.60 Newton per mm square. $86.60. We check your answer. Sigma t is equal to 86.60 Newton per mm square. And third value we have to calculate resultant. It is very simple. Sigma r is equal to sigma n square plus sigma t square. So sigma r is equal to 70 bracket square 86.60 bracket square sigma r 111.35 Newton per mm square. So this is the resultant stress. Please check your answer, verify your answers. By mistakes, we are forget to take the negative sign of the sigma y and we are doing the calculations. But your answers will be different. So do the calculations properly and then go for the further calculation. Okay, have finished, have calculated, everyone have got the answers. Those who are attending online have got these three answers: 70, 86.60 and 111.35 Newton per mm square. Any problem for the calculation? Have got the answers. Do the calculations properly, take the time. One by one, do the separate simplification. If you are unable to calculate directly, go for the different calculation, and at the end you have to go for the addition, subtraction wherever it is required. Okay, finish. Have got the answers. Okay. Now one more problem we'll take on the case number 2. So this is a statement in front of you. See, a block of 100 mm by 50 mm by 7.5 mm thick. A block of three-dimensional body they have given. A block of 100 mm by 50 mm by 7.5 mm thick, subjected to uniformly distributed stresses shown in figure. Subjected to uniformly distribution stresses shown in figure. Compute normal and shear stress developed on inclined plane. Compute normal and the shear stress developed on inclined plane. If you read the statement carefully, whatever the figure they have represented, in this particular figure, initially that theta value is not mentioned here. Please keep in mind. This theta is not given. They have represented only position of theta. They have represented only position of theta which is present at this particular C corner. The distribution of forces they have given. Distribution of forces on the figure you can see. So both three-dimensional body and their two-dimensional concept they have represented here. Dimensions are given: 100 mm length, 50 mm depth or width and 7.5 mm thick. Three-dimensional body मध्ये त्यांनी thickness कुठली कन्सिडर केली बघा. कुठली कन्सिडर केली thickness? आतापर्यंत आपण thickness कुठली कन्सिडर करत होतो? Vertical dimension. बरोबर आहे. Vertical dimension we have considered the thickness, but here they have mentioned 7.5 mm थिक म्हणजे बघा 7.5 mm तुमचं कुठलं डायमेन्शन आहे इन्क्लाइन डायमेन्शन आहे दिस इज युअर इन्क्लाइन डायमेन्शन 7.5 mm थिक okay this is the 100 mm length and this 50 mm is given as a vertical dimension 3-dimensional body मध्ये हे horizontal dimension म्हणजे तुमची length of body झाली inclined dimension म्हणजे त्यांनी thickness consider केलेले आहे and this vertical dimensions they have considered as a 50 mm okay the distribution of force you can see distribution of force this is the px and this is the py this is the px and this is the py आणि त्याच्या लेफ्ट साइडला दुसरे एक फिगर दिलेले आहे मग मला सांगा from the 3-dimensional body which section they have considered बघा त्यांनी फिगर कुठली ड्रॉ केली आहे 25 kilonewton along the x axis and 35 kilonewton along the y axis okay 25 kilonewton along the x axis and 35 kilonewton along the y axis and which areas they have considered for the calculation of px for the calculation of sigma x and sigma y so here the cross sectional area for the sigma x calculation they have given by the hatching line समजतंय this is the hatching line and one more hatching line is given at the top side so which areas we have to consider for the calculation that we have to understood through this particular statement getting the 3-dimensional body is purposefully given to calculate the area ax and area ay आतापर्यंत जे काही दोन प्रॉब्लेम आपण डिस्कस केले त्याच्यामध्ये तुम्हाला क्रॉस सेक्शनल एरियाची गरज लागली नाही बिकॉज डायरेक्ट स्ट्रेस दे हॅव गिवन सिग्मा एक्स आणि सिग्मा वाय डायरेक्ट ह्या व्हॅल्यू तुम्हाला स्टेटमेंट मध्ये दिलेल्या आहेत बघा इथे 120 80 इन द प्रिव्हियस प्रॉब्लेम 150 so need not required to take the effect of areas but here in the third problem they have given the 3-dimensional body separately for the area calculation so first of all we have to calculate the sigma x we have to calculate sigma y and then we have to go for the normal and tangential stress calculation in the statement they have not mentioned the theta value theta 30 आहे का 60 आहे का 180 आहे काहीच माहित नाही but they have represented the position of theta at the corner C but it is not given they have represented the position of theta at this particular corner now first of all calculate the sigma x and sigma y so tell me ax and ay so what will be the two values for the ax calculation what is the area ax मी कुठल्या हॅचिंग लाईन इंडिकेट केलं बघा ह्या साइडला मग कुठला एरिया येणार आहे which value by which value how much हा एरिया आपल्याला कन्सिडर करायचा आहे एरिया ax साठी मग हा एरिया साठी कुठले डायमेन्शन आहेत हे इन्क्लाइन डायमेन्शन बाय वर्टिकल डायमेन्शन किती दिलेला आहे 50 हे डायमेन्शन किती दिलंय 50 आणि इन्क्लाइन डायमेन्शन 7.5 मग एरिया ax काय झाला सांगा 7.5 into 50 what is this product 375 mm square this is the area ax then area ay top side and bottom side मग top side आणि bottom side मध्ये this dimension and this inclined dimension मग हे front side चं dimension हे किती आहे 100 mm हे inclined dimension किती आहे 7.5 so 100 into 7.5 how much 750 mm square so in front of that from 3D figure so we have calculated area ax and area ay so what is the px value they have mentioned in the figure what is the px value they have mentioned in the figure 25 kilonewton, and what is the Py? 35 kilonewton. So by using these two values, we can calculate. So here I will write Px is equal to 25 into 10 raised to 3 Newton, and Py is equal to 35 into 10 raised to 3 Newton. So both the figures they have given in the statement. दोन्ही figure तुम्हाला दिलेले आहेत. 2-dimensional figure तुम्हाला Px आणि Py इंडिकेट करण्यासाठी आणि थीटा इंडिकेट करण्यासाठी दिलेले आहे, आणि 3-dimensional फिगर हे तुम्हाला स्पेसिफिक एरिया कॅल्क्युलेट करण्यासाठी दिलेले आहे. प्लीज कीप इन माइंड. So now first of all calculate sigma x. Sigma x is equal to Px upon Ax. So Px is equal to 25 into 10 raised to 3 divided by area Ax 375. So you will get the sigma x. Sigma y is equal to Py upon Ay, which is equal to 35 into 10 raised to 3 divided by 750. So tell me these two values. Which one? Sigma x is equal to 66.66 Newton per mm square. And what is sigma y? Do the calculation. 46.66 Newton per mm square. So these are the two stress values. Once again, look at to the figure. 2-dimensional body and the 3-dimensional body they have given. 2-dimensional body and the 3-dimensional body they have given. Two-dimensional body they have given for the position of Px and Py location as well as theta location, but theta value is not mentioned. आता हा जो पोर्शन कन्सिडर केला 2-dimensional बॉडी जो तुम्हाला समोर दिसतोय, तो पोर्शन 3-dimensional बॉडी मध्ये कुठे आहे? सो दिस इज पॉइंट A, दिस इज B, दिस इज C and दिस इज D. म्हणजे ही लेफ्ट साइडची जी काय फिगर ड्रॉ केलेली आहे ही फिगर म्हणजे हा तुमचा फ्रंट साइड ऑफ द सेक्शन. समजतंय? फ्रंट साइड ऑफ द सेक्शन. आणि ह्या फ्रंट साइड वर हा म्हणजे तुमचा सिग्मा एक्स आला आणि हा वरचा म्हणजे तुमचा सिग्मा वाय आला. मग सिग्मा वाय हा ह्या मायनर प्लेन वर ऍक्ट झालेला आहे आणि ह्या मायनर प्लेनचं डायमेन्शन किती आहे? 100 mm. बरोबर आहे, खाली 100 mm. आणि हा मेजर प्रिन्सिपल प्लेन म्हणजे वर्टिकल, ह्या वर्टिकल मेजर मायनर प्रिन्सिपल प्लेनचं डायमेन्शन किती आहे? 50 mm. बरोबर, इकडे 50 mm इंडिकेट केले बघा. गेटिंग? सो purposefully they have given the 3-dimensional and the 2-dimensional figures. Now I have to calculate normal and tangential. Normal आणि tangential stress find out करण्यासाठी आपल्याला sigma x माहित आहे, sigma y माहित आहे. But for that we have to calculate the theta also. Okay, so how to calculate the theta? How to calculate the theta? Theta is located at the corner point C. Only position of theta is given, but their magnitude is not given. So here for the calculation of theta we have to apply one trigonometric rule. कुठला रूल अप्लाय करायला लागेल सांगा मला. Which 90? 90 minus 40. What is 45? तो 45 डिग्री कुठे सांगितलं? No. Already I have told we have to apply one trigonometric rule. माहित आहे तिथं थीटा तुम्हाला दिलाय एका कॉर्नरला. कुठला ट्रिग्नोमेट्रिक? साइन, कॉस, टॅन, सेक, कोसेक. कुठला रूल ऍप्लिकेबल होतोय सांगा मला. टॅन रूल ऍप्लिकेबल होतोय का? व्हॉट इज द टॅन रूल? फ्रंट साइड अपॉन ऍडजस्टंट साइड. फ्रंट साइडचं डायमेन्शन तुम्हाला दिलंय का? Adjacent side dimension तुम्हाला दिले का? So we can apply our simple rule, that is from figure apply tan theta is equal to, what is the front side? AB. What is the adjacent side? BC, which is equal to AB is equal to 100, BC is equal to 50. So theta is equal to tan inverse of 100 divided by 50, which is equal to, what is this value? 63.43 degree. This value we have got. Okay, but as per our sign conventions of the theta, whether that theta will be the positive value or negative value, negative value. So for this theta you have to write down the negative sign, and in front of that you have to write down by sign conventions. By the sign conventions. So by applying the tan theta rule or by applying the tan rule, we have calculated theta value, and after the calculation of theta, we have verified it whether that value we have to take positive or negative. That is, we have to take negative. Now the theta value we have calculated, sigma x, sigma y we have calculated. Now go for your further calculation of normal and tangential stress on the inclined plane. So you are having all the formulas. Go by the calculation and tell me the answers. So I will write down the formula. Sigma n is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta. This is the first formula. Second, sigma t formula is equal to sigma x minus sigma y divided by 2 into sine 2 theta. Into sine 2 theta. So put all the values. Sigma n is equal to sigma x is equal to 66.66. So 66.66 plus 46.66 divided by 2 plus 66.66 minus 46.66 divided by 2 multiply by cos 2 into minus 63.43. Tell me the sigma n value. Similarly, sigma t is sigma x, sigma n 50.66 Newton per mm square. So do the calculation and send me the answers in the chat box. What is the first normal stress? Normal stress is equal to both stresses are tensile, so you have to take their positive signs only. Sigma n 50.66 minus 8.00 means minus 8 Newton per mm square. So sigma n is equal to 50.60 and sigma t is equal to minus 8 Newton per mm square. So what is your send your the chat box? Have got this answer? Sigma r. Whether it is asked? It is not asked. You can check sigma r is equal to how much? 51.28. Please check the answers, all the answers. Send your all the answers in the chat box. Send your all the answers in the chat box. sigma n, sigma t, and sigma r. If you make the square of -8, it becomes plus. त्यामुळे त्या मायनसचा इफेक्ट रिझल्टंट मध्ये काही होत नाही. -8 चा स्क्वेअर पॉझिटिव्ह व्हॅल्यू येणार आहे तुमची. Okay, 50.60 -8 and 51.28 Newton per mm square. So these are the three values. So through this particular problem, we have to understood the concept, how the theta is calculated by using the tan rule, and one more three-dimensional body is given specifically for the area calculations. Which areas we have to consider for the x and which area we have to consider for the y, that we have to understood. So send your answers in the chat box. Only one student has sent the answer in the chat box. So due to the electricity problem, I am unable to share the screen. But all the values you are having, all the formulas you are having, send your answers in the chat box. Do the calculations properly. Okay, am I audible? Is my screen is visible? Okay, so this was the problem. So I think data is not saved due to the electricity problem. Everyone, have you calculated? Have you got the answers? So those who are attending online, have you got the answer? Normal stress is equal to 50.66. Tangentiality is equal to minus 8 Newton per mm square, and last one resultant is also equal to 51.28. Okay, so this was the last problem based on the case number 2. Then we will move to the case number 3. So put the next heading. Case number 3. Member or body subjected to biaxial stresses together along with shear stress. This is not a triaxial condition. Please keep in mind. For the triaxial condition, we have to apply one more force or one more stress in a z direction. But during the principal stress calculation or in this particular chapter, the effect of z direction we have not considered in any calculation. So this is not a triaxial condition. 3 प्रकारचे stresses आहेत, पण it is not applied in the 3 axis. Only sigma x and sigma y is present, and along with sigma x and sigma y, one more stress is there, that is shear. Now you can see the position of shear. It is parallel to the principal planes. If you see the position of shear stress tau, it is parallel to the principal plane, because the shear stress, shear force are always parallel to the cross-sectional areas, and normal stresses or direct stresses are always perpendicular to the cross-sectional areas. Please keep in mind. Draw the figure, and from that figure you have to understand the concept, how the tau is located. So the case number 3 is member or body subjected to the biaxial stress along with shear stress. Draw the figure, and you have to understand the basic difference between case number 2 and case number 3. Means in this case number 3, whatever the normal stress and tangent stress we are going to calculate on the inclined plane, during that calculation we have to consider the effect of sigma x, sigma y, and the shear stress also. That is tau. आता इथं आपण इन्क्लाइन प्लेन वरचा टॅन्जेन्शियल स्ट्रेस किंवा शियर स्ट्रेस आपण सिग्मा टी ने इंडिकेट करतोय, आणि प्रिन्सिपल प्लेन वरचे शियर स्ट्रेस आपण टाउ ने इंडिकेट करतोय. बघा, दिस इज शियर स्ट्रेसेस ऑन द oblique principal planes, and whatever the sigma t is there, this sigma t is also shear stress. This sigma t is also your shear stress, but it is on the inclined plane. ह्याला shear पण म्हणू शकतो आणि tangential पण म्हणू शकतो. So draw this particular figure. Okay, take this sign conventions of the shear stresses. So take this sign convention. It is very important for the case number 3. Understand the difference between figure A and figure B. Only shear stresses are represented on the principal plane. Sigma x and sigma y आपण represent केलेला नाही. जसं सिग्मा एक्स आणि सिग्मा वाय ला आपण साइन कन्व्हेन्शन डिसाइड केलेले आहे फॉर टेन्साइल पॉझिटिव्ह फॉर कॉम्प्रेसिव्ह निगेटिव्ह. Similarly, for the shear stress also we have to consider their sign. Which figure or for which figure we have to take positive shear stress and for which figure we have to take the negative shear stress. Without these sign conventions, we are not able to solve the numericals on the case number 3. Positive and negative. Okay, now what we have to understand through this particular figure A and B. See, the figure A and figure B. So in your numerical, the set of the shear stress will be given in the form of figure A also, and set of the shear stresses will be given in the figure B also. But which we have to take positive and which we have to take negative, that we have to decide as per the direction of this particular shear stresses. जे काय shear stresses च्या direction आहेत, चार shear stress च्या, according to that directions we have to decide that which will be the positive and which will be the negative. So one simple definition I will tell. The shear stress will be considered as a positive if set of shear stress will be in the form of figure A. माहित नाही. The shear stress will be the positive if the set of shear stress will be given in the form of figure A, and the set of and shear stress will be the negative if the set of shear stress will be given in the form of figure B. याच्यावरून आपल्याला क्लिअर होत नाही की कुठलं पॉझिटिव्ह आणि कुठलं निगेटिव्ह. So for more understanding, we have taken major principal plane. We have taken major principal plane for deciding which will be the positive and which will be the negative. So we have to take shear stress positive if shear stress is rotate in anti-clockwise direction with major principal plane. Getting? We have to take shear stress positive if the shear stress acting on major principal plane is rotate in anti-clockwise direction. बघा हा कुठला प्लेन आहे? मेजर प्रिन्सिपल प्लेन आहे. ह्या मेजर प्रिन्सिपल प्लेनला हा शियर स्ट्रेस अँटी क्लॉकवाइज मध्ये आहे का क्लॉकवाइज मध्ये आहे? अँटी क्लॉकवाइज मध्ये आहे. तसंच वन मोर मेजर प्रिन्सिपल प्लेन, ह्या मेजर प्रिन्सिपल प्लेनला हा शियर स्ट्रेस अँटी क्लॉकवाइज आहे का क्लॉकवाइज आहे? अँटी क्लॉकवाइज. सो वी हॅव टू टेक दिस सेट ऑफ द शियर स्ट्रेस ऍज अ पॉझिटिव्ह. बरोबर. आता ह्याच्यामध्ये जर आपल्याला मेजर प्रिन्सिपल प्लेन कन्सिडर केले असेल तर फिगर बी मध्ये पण आपल्याला कुठला प्रिन्सिपल प्लेन कन्सिडर करावं लागतील साइन कन्व्हेन्शन साठी? मेजर असेल. तर इन फिगर बी this particular shear stress is rotate in clockwise or anti-clockwise? Clockwise. Similarly, another major principal plane, ह्या major principal plane ला हा shear stress कुठल्या डायरेक्शन मध्ये आहे? Clockwise. So we have to take this shear stress as a negative. So please consider in figure A and in figure B. In figure A and figure B, we have to concentrate only on which plane? Major principal plane. इकडचं साइन कन्व्हेन्शन करताना मेजर प्रिन्सिपल प्लेन आणि इकडचं कन्सिडर करताना मायनर प्रिन्सिपल प्लेन. बघा इकडचा मेजर प्रिन्सिपल प्लेन कन्सिडर केला तर शियर स्ट्रेस हा मेजर प्रिन्सिपल प्लेनला अँटी क्लॉकवाईज आहे, बरोबर. आणि फिगर बी मध्ये जर आपण मायनर प्रिन्सिपल प्लेन कन्सिडर केला तर इथं पण कसा आहे, अँटी क्लॉकवाईज आहे, बरोबर. आपली साइन कन्व्हेन्शन सॅटिस्फाय होतील का? नाही. एक तर घेताना दोन्हीकडे पण मायनर प्रिन्सिपल प्लेन घ्या किंवा दोन्हीकडे पण मेजर प्रिन्सिपल प्लेन. जस्ट बट फॉर आवर बेटर अंडरस्टँडिंग आपण काय कन्सिडर करतोय, युअर थिटा अँगल शुड बी विथ ओनली व्हर्टिकल प्लेन आणि मेजर प्रिन्सिपल प्लेन. आपण जास्तीत जास्त कॅल्क्युलेट करताना आपण मेजर प्रिन्सिपल प्लेनचाच इफेक्ट कॅल्क्युलेशन मध्ये जास्त कन्सिडर करतो. त्यामुळे इथं शियर स्ट्रेसेसचे पण साइन कन्व्हेन्शन कन्सिडर करताना आपण कुठला इफेक्ट कन्सिडर करूया, मेजर प्रिन्सिपल प्लेन. जर मेजर प्रिन्सिपल प्लेनला जर तुमचा शियर स्ट्रेस हा अँटी क्लॉकवाईज डायरेक्शन मध्ये जर रोटेट होत असेल तर तो शियर स्ट्रेस आपण कुठला घेऊया, पॉझिटिव्ह. आणि मेजर प्रिन्सिपल प्लेनला जर तुमचा शियर स्ट्रेस अँटी क्लॉकवाईज रोटेट होत असेल तर दॅट शियर स्ट्रेस वी हॅव टू कन्सिडर ऍज अ निगेटिव्ह. त्यामुळे फिगर ए मध्ये जर तुम्ही बघितलं तर हे दोन्ही शियर स्ट्रेसेस ह्या पॉइंटला कॉन्सन्ट्रेट होते, वरचे दोन शियर स्ट्रेसेस ह्या पॉइंटला कॉन्सन्ट्रेट म्हणजे कॉर्नर साइड. पण तुम्ही निगेटिव्ह शियर स्ट्रेसेस मध्ये जर बघितलं तर निगेटिव्ह मध्ये शियर स्ट्रेसेस ह्या दोन पॉइंटला कॉन्सन्ट्रेट होते आणि खालचा सेट ह्या दोन पॉइंटला कॉन्सन्ट्रेट होते, म्हणजे गेटिंग डिफरन्स बिटवीन पॉझिटिव्ह अँड शियर स्ट्रेस. त्यामुळे घेताना वी हॅव टू कन्सिडर द मेजर प्रिन्सिपल प्लेन. So that I will give the explanation. Write down few things below the figure. Shear stress is considered as positive. So write down in your notebook below the figure. Important note. Shear stress is considered as positive. Shear stress is considered as positive if set of shear stress, if set of shear stress, if set of shear stress acts shown in figure A, acts shown in figure A, acts shown in figure A, that is I dot E dot, that is in figure A, in figure A, if shear stress is rotate in anti-clockwise, if shear stress is rotate in anti-clockwise to major principal plane, to major principal plane, take tau as a positive, take tau as a positive, full stop. Next line, the shear stress is considered as a negative, the shear stress is considered as negative, is considered as negative if set of shear stress acts, if set of shear stress acts shown in figure B, set of shear stress acts shown in figure B, that is shear stress rotate in clockwise direction, that is shear stress rotates in clockwise direction to major principal plane, to major principal plane, take tau as a negative, take tau as a negative. सिंपल. मेजर प्रिन्सिपल प्लेनला जर तुमचा शियर स्ट्रेस अँटी क्लॉकवाईज रोटेट होत असेल तर तो शियर स्ट्रेस पॉझिटिव्ह का निगेटिव्ह, दोन्ही मध्ये आपण फक्त मेजर प्रिन्सिपल प्लेनचाच इफेक्ट कन्सिडर करणार आहे. मग मेजर प्रिन्सिपल प्लेनला तुमचा शियर स्ट्रेस हा अँटी क्लॉकवाईज रोटेट होत असेल तर तो पॉझिटिव्ह घ्यायचा का निगेटिव्ह घ्यायचा? पॉझिटिव्ह. आणि त्याच मेजर प्रिन्सिपल प्लेनला जर तो क्लॉकवाईज रोटेट होत असेल तर तो काय घ्यायचा? निगेटिव्ह. त्यामुळं हे साइन कन्व्हेन्शन कन्सिडर करताना फक्त मेजर प्रिन्सिपल प्लेनचाच विचार करायचा. किंवा तुम्हाला जर हे दोन सेट लक्षात राहत असतील की दोन शियर स्ट्रेस कुठल्या पॉइंटला कॉन्सन्ट्रेट झाल्यानंतर तो पॉझिटिव्ह आहे आणि कुठल्या पॉइंटला कॉन्सन्ट्रेट झाल्यानंतर तो निगेटिव्ह आहे, असं जर लक्षात राहत असेल तसं लक्षात ठेवा. किंवा मेजर प्लेनला तो क्लॉकवाईज आहे का अँटी क्लॉकवाईज आहे तसं लक्षात ठेवा. Getting? So these are the sign conventions we have to use during the calculation. Okay. Then this is the list of the formulas. So take these formulas in your notebook. Again, there is a change in only normal and tangential stress. Otherwise, resultant angle of obliquity and tau max, it is same. So first formula is sigma n is equal to, in bracket, sigma x plus sigma y bracket complete plus sigma x minus sigma y into cos 2 theta plus tau into sin 2 theta. Second formula shear or tangential, in bracket sigma x minus sigma y divided by 2 into sin 2 theta minus tau into cos 2 theta. फक्त ह्याच्यामध्ये ऍड काय झाले केस नंबर 2 पेक्षा, प्लस टाउ साइन 2 थीटा आणि दुसऱ्याला माइनस टाउ कॉस 2 थीटा. अदरवाइज केस नंबर 2 formula will be same. Only they have considered the effect of tau in the form of tau sin 2 theta and minus tau cos 2 theta. Otherwise it is similar to the case number 2. Write down the formula properly, where positive sign is there, where negative sign is there. That is very important. Okay, finish. Okay, now the first problem we'll solve and then we will stop. See, a machine component is subjected to the stresses shown in the figure. Figure already दिलेला आहे, त्या figure वर distribution of stresses, their direction, their magnitude, their nature, it is represented. A machine component is subjected to the stresses shown in the figure. Find normal, shear and resultant stress on oblique plane inclined at 30 degree with vertical face. The vertical face म्हणजेच काय? Vertical face म्हणजेच काय? 30 degree angle is given with vertical face shown in the figure. Vertical face म्हणजेच काय असणार आहे तुमची? Vertical plane किंवा त्यालाच आपण काय म्हणतोय? Major principal plane. Vertical face, vertical line, vertical plane, major principal plane, meaning of all are same. So here the figure is given. In the figure they have represented the direction and magnitude of sigma x, then direction and magnitude of sigma y, direction and magnitude of shear stresses also. So at the bottom side they have not represented shear stress, so this shear stress will be like this. बघा दोन्ही shear stress हे एकाच पॉइंटला कॉन्सन्ट्रेट झाले पाहिजे बरं का. The stress बघा एक shear stress मेजर प्रिन्सिपल प्लेन वरचा आणि दुसरा shear stress मायनर प्रिन्सिपल प्लेन वरचा, हे एकाच पॉइंटला कॉन्सन्ट्रेट झाले पाहिजे. बघा हे एका पॉइंटला कॉन्सन्ट्रेट झाले तसेच खालचे पण ह्या पॉइंटला कॉन्सन्ट्रेट होणार. दॅट इज 25 न्यूटन पर mm square. So draw the figure. The 30-degree angle is already given with vertical face. ज्यालाच आपण वर्टिकल प्लेन पण म्हणतो किंवा मेजर प्रिन्सिपल प्लेन पण म्हणतो. Draw the figure, represent all the stresses on the figure, sigma x, sigma y, their magnitudes, their natures, both are tensile. Tau. Which one? 100. Both stress value will be same, equal in magnitude, opposite in nature. इकडचा वेगळा तिकडचा वेगळा असणार आहे. इक्वल इन मॅग्निट्यूड, अपोजिट इन नेचर. त्यामुळे सिग्मा एक्स ची व्हॅल्यू दोन्हीकडे सेम असणार आहे, सिग्मा वाय ची व्हॅल्यू दोन्हीकडे सेम असणार आहे. Draw the figure properly, represent the position of the shear stresses, because which we have to take, positive or negative, that we have to decide as per our sign conventions. We have to check the shear stress with major principal plane, clockwise or anti-clockwise, and accordingly we have to take the sign conventions. Okay, after the figure, you write down all the given parameters once again. So here, sigma x is equal to 100 Newton per mm square. In bracket, it is tensile. Then sigma y is equal to 50 Newton per mm square. In bracket, tensile. Theta is equal to plus 30 degree. It is already given with vertical plane, therefore by sign conventions. And one more value they have given, tau is equal to 25 Newton per mm square. Now this 25 Newton per mm square we have to check with major principal plane. Getting? मेजर प्रिन्सिपल प्लेनला तो क्लॉकवाइज रोटेट होतोय का अँटी क्लॉकवाइज रोटेट होतोय? सो व्हॉट विल बी दिस डायरेक्शन? अँटी क्लॉकवाइज. तसंच इकडे पण कसं रोटेट होतोय? सो वी हैव टू टेक दिस एज अ पॉझिटिव्ह और निगेटिव्ह? पॉझिटिव्ह. सो हियर plus 25 Newton per mm square you have to write, and in front of that you have to write down by sign conventions. This is very important. By the sign conventions. So these are the given parameters, and we have to calculate normal stress on oblique plane, tangential stress on oblique plane, and also we have to calculate the resultant stress also. So for the calculation of normal, we require sigma x, sigma y, theta, and tau. So all values are given. So directly you can write down the formula. Sigma n is equal to, first one, sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta plus tau into sin 2 theta. So one by one, put all the values. Sigma x is equal to 100 plus 50 divided by 2 plus again 100 minus 50 divided by 2 into cos 2 into 30 plus tau 25 into sine 2 into 30. So one by one, 100 plus 50 divided by 2, it is equal to 75 plus separate this calculation 100 minus 50 divided by 2 into cos 60. ह्याचं separate calculation केलं तर किती येते? No problem. Your answer should be same. So here 25. I will write 100 minus 50, 25 into cos 60, correct? Plus tau 25 into sin 60. So what will be your answer? Correct. 109.15 Newton per mm square. You check your answers. You can do the direct calculation in your calculator. You can go for the simplification in your calculation. No problem. Your answer should be same. If you are unable to do the simultaneous calculation, make the separate calculation of sigma x plus sigma y. Then sigma x minus sigma y divided by 2 into cos 2 theta. त्याचं separate calculation करा. Tau into sin 2 theta. त्याचं separate calculation करा. आणि सगळ्यात शेवटी मग बेरीज करा. If you are unable to do the simultaneous calculations. 109.15 Newton per mm square. Please check. Have you got the answer or not? Sometimes we forgot to apply some brackets in the calculation, and due to which your calculation becomes wrong. So try to make the separate calculation of each and every term, find out their separate values, and then at the end go for the addition, subtraction wherever it is required. Have you got 109.15? Have you got 109.15? येते का calculation? 109.15. Then second formula of tangential stress. Sigma t is equal to sigma x minus sigma y divided by 2 into sin 2 theta minus tau into cos 2 theta. So sigma t is equal to 100 minus 50 divided by 2 into sin 2 into 30 minus 25 into cos 2 into 30. So here I will write sigma t is equal to 25 into cos 60 minus sin minus 25 into cos 60. So what will be the sigma t, tangential stress? 9.15 Newton per mm square. 9.15 Newton per mm square. And sigma r, okay, sigma r is equal to resultant of sigma n square plus sigma t square. So sigma r is equal to square root of 109.15 bracket square 9.15 bracket square. First of all, we have to make the square and then take the square root. So sigma r is equal to 109.53 Newton per mm square. You check your all the answers. Calculation is very simple for all the three cases, but only we have to remind the concepts. We have to remind the sign conventions of the theta. We have to remind the sign conventions of sigma y, sigma x, sigma y, and the shear stress. So we have to keep all the formulas in your mind. What is the formula of sigma n, sigma t for case number 1, case number 2, and for case number 3. So sigma n is equal to 109.15, sigma t is equal to 9.15, and resultant stress is equal to 109.53 Newton per mm square. So this is the calculation. So in the case number 3, the sign of tau plays very important role. If you are unable to consider the proper sign conventions of the tau, your calculation will be wrong. So for that purpose, we have to compare the shear stress value with major principal plane. Clockwise or anti-clockwise. For that purpose, I have given that important notes. You have to keep in your mind. Okay. So with this, today we'll stop. Again, remaining 2-3 problems are there based on the case number 3 that we'll take in the next lecture, and immediately we'll start the graphical method. So in the next lecture, be ready with your all the drawing instruments. So for that purpose, to draw the circles, drawing book is not required. Use your regular notebook. You have to make your notebook horizontal, and you have to draw that particular more circle in the figure. So in the next lecture, be ready with all the instruments. It is compulsory required. Without that, we are unable to use that graphical method for the calculation. Okay. So with this, today we will stop here. In the remaining lecture, we'll take the another problems.